So hi everybody. Today what we're doing is a lab dealing with standing waves. So I just want to remind you real quick what a standing wave is. So unlike a traveling wave or a propagating wave, a standing wave doesn't go anywhere. It's confined to some area or some volume or some length. So the simplest way to think about a standing wave is a wave on a string, let's say a guitar string, held down at both ends. You pluck the string, you create a standing wave on that guitar string. In this lab, we're going to be dealing with a very similar sort of situation, a standing wave on a string. But the way we're going to create the standing wave and make sure that it keeps going for long periods of time, we're going to use a motor. So this is our motor. Basically what it does is very simple. The end of this piece of metal will vibrate up and down at some fixed frequency as long as the motor is plugged in. We're going to attach a string to this end. And so the string is going to be vibrating up and down with that same exact frequency. Now if the string is held down at the other end, again we'll have a standing wave because that wave has nowhere to go, and that standing wave will have the same frequency that this motor has. The actual goal of today's lab, what we're ultimately going to be measuring at the end of the day, is the frequency of this motor, because that's something that is going to stay the same throughout our experiment. Okay, so now let's take a look at our experimental setup when it's all on the table. So at the left end of the table we have our motor, and it's attached to the stand that you see here on the right side. And the string, which is pretty thin and hard to see, but hopefully you can see it right now, the string is attached to that movable piece of metal at the end of our motor, which is vibrating up and down. So if we follow the string along the table like this, to the left side, we'll see that we have a pulley. Okay, so that pulley supports the other end of the string and it holds it down. Now hanging from that pulley, we have some weights. And we can change the amount of weight that's hanging from the pulley, just by adding or subtracting paper clips or other types of weights. So if you think about it, the more weight we hang from the end of the pulley, the more tension there is going to be in the string. So that is essentially how we change the tension, by changing the amount of weight that's hanging from the end of the string. And so this is something that we're going to have to fine-tune throughout the experiment. So we'll be using paper clips. Each paper clip is about 1 gram, so we can vary the hanging mass by about 1 gram. And so our goal is to change the tension in the string by changing the hanging mass, and thereby changing the standing wave pattern we get on the string. So this is the first standing wave pattern that we're going to create in today's lab. It's a standing wave with 2 complete loops on the string. So let's take a look at one of these loops. There it is. And on either side of that loop, you can see that we have a node, which is a point where the string is not moving at all. So right there where the pulley is, that would be considered a node. This would also be considered a node on the right side of that loop. Let me show you the second loop. It's right here. And again, on the right side of that loop, we also have a node. So those are the 2 complete loops on the string. Well, actually, if you look over here going past that, you might say that looks like another loop right there, but it actually doesn't really count, and here's why. So if we follow this over to the point of attachment of the string where our motor is located, you'll notice that the string basically ends at this point where the motor is vibrating it up and down. So this cannot be considered a node because it is moving up and down. The string is moving up and down at this point. So in other words, this is not a complete loop because it doesn't end at a node. We're only going to be considering the 2 complete loops that came before that, which again are from the pulley to the first node and then to that second node. Okay, so those are the 2 complete loops. So the first measurement we want to take from this is what is the total length of string that contains those 2 loops. So here's what I've done. I've put the end of this 2-meter stick right where the pulley is. And then if we just sort of follow along and then locate where that second node was, so that's the end of our 2 loops. I know it's very hard to see on video, but just take my word for it, it's about 95.3 centimeters for the total length of string containing those two loops. So 95.3 centimeters is the total length for two loops. And the next thing we'll want to measure is how much mass is hanging from the end of the string in order to create those two loops. So this is something I spared you the details of showing, but basically I had to fine-tune the mass that was hanging by just trial and error, seeing exactly how many weights and paper clips it took to get two loops on the string. So now what we're going to do is just figure out what the total mass hanging there actually is. And if we put all those weights and paper clips onto the scale, we'll see that it balances out right around 104.7 grams. So the hanging mass is 104.7 grams. Okay, and now to show the next standing wave, which has 3 loops in it, 3 complete loops that is. Now, as we go on and make more and more loops, one thing that happens is the amplitude of the vibrations goes down. So you can see this one is a little harder to actually see than the last one, but you can see there's a loop right there, followed by a node, followed by a second loop, and then another node, and then a third complete loop, and then another node right there. And this last little bit is not a complete loop, so we don't count it. So I've already made the measurements. The total length of string for those 3 loops is 106.5 centimeters. And the total mass that's currently hanging from the string, okay, right there, is 58.5 grams. Okay, so the remainder of the lab goes in much the same way. Basically, we, through trial and error, change the amount of hanging mass on the string to get different numbers of loops in our standing wave pattern that's on the string. So, as you can notice, we're actually decreasing the amount of mass that we're hanging to get more loops. So, we're going to keep taking mass off through trial and error, and then seeing exactly how much mass we need to hang to get 4 loops, to get 5 loops, 6, 7, and then 8 loops, and we'll stop there. And again, for each one, we'll measure the hanging mass, and then we'll measure the total length of all of those loops. So I'm not going to show you that in this video. I'm just going to put the data up on the screen at the end of the video, and that's what we'll be using for our analysis in today's lab. So that's all for today. I hope you're having a good week out there. I'll see you in the next one.